Okay, this one is tricky if it's been a little while since you've done it, but it is a very fair question, and it's typically on the AP exam. So this is a real important one, and reading the question, reread the question. When you think you're done with the problem, reread the question. All right, here we go. Okay, we're looking for the maximum area. Okay, we're trying to maximize area. Let's just start with that. We're going to need to write an equation for area, and then to maximize it, we're going to want to find its derivative and set it equal to 0. And if there's more than one option, make sure it changes from positive to negative. Okay, that's our goal. Well, shoot, I didn't even read the problem. Area of what? It's a rectangle that's inscribed within this parabola. So usually they give you the picture, but whatever. We want to maximize a rectangle that fits inside here. I don't know how big it's going to be. Okay, maybe it's like that. Maybe a bigger area would be if I drew it more like this. All right, but somehow there's a rectangle inside there. Okay, so we need to find the area of that rectangle and maximize it, find its derivative. The key for this is knowing that since this is centered at the origin right here, then from here to here we're going over some amount x. We don't know what it is, but this would have to be the same amount because it's symmetric. We're going up y. The point right here on this curve, oops, hold on. The point right here on the curve is over x. Timeout, technically. Okay, this point right here is over x and up y. That's what that point is right there. Okay, but we need the area of that rectangle. So it's this total length and total width. So the area of the rectangle would be 2x times y. Then we're going to want to get rid of one of those variables. So to get rid of this y, or this y, you're going to use the equation of y, which is sitting right there. So rewrite it. Area is equal to 2x times cosine x. All right, now this is a calculator problem, so we've got more than one way to do this. What we've always done for pretty much all of these problems is actually find the derivative of that. Okay, well, the derivative of this would be a product rule. Okay, and that's probably what all of you would have done. And you can do it that way. It is going to be more time consuming. Okay, I can find the derivative and I can find when that derivative is 0 using my calculator. That's what you would normally probably do. But since this is a calculator, it's a calculator question, I want the maximum of this and they're letting me use a calculator. I can graph this and look for its highest height. So much easier, okay? So that's going to be the easy way to do it if you know how to play with the window. And you've got a few choices to check here, so it's even easier. So don't waste time doing the derivative. Just use your common sense. Find the max of this equation. Put this into your calculator. Make sure you're in radian mode. And look for when it has the highest value. Duh! You can even guess and check these things, okay? But when you do that, and so basically, I don't know what this graph looks like, but whatever it looks like, look for its overall highest number, okay? Now, when you find that highest number, your x coordinate, you're going to have an x and a y, okay, of whatever that highest value is, and your calculator will give it to you, okay? Now reread the question, okay? What is the maximum area? The x in this problem is going to give me what the width of half the rectangle should be. The area would be the y-coordinate, because area is the y-coordinate in this equation. So if you understand what I just did, that is the most effective way to do the problem. Just graph the original and know what the x and y coordinates actually stand for, okay? Now I'm going to do it by doing the derivative, which is more work, and you'll interpret it differently but get the same answer. But I think that's maybe what a lot of people are thinking you should do. So I'm going to hit pause for a minute and reset this up, and I'm going to actually find the derivative. But honestly, again, the easiest way is recognize common sense. The maximum is going to be at the freaking maximum if I can graph it. If they're stupid enough to let me use my graphing calculator, then I can graph it and find the highest value, but make sure I know the difference between what does the x stand for and what does the y stand for. And they wanted area, so we're looking at the y coordinate. Okay, option 2. Now we're going to find the derivative, set it equal to 0. Well, the derivative of this is a product rule. Derivative of 2x is 2. Derivative of cosine is negative sine. Crisscross. So my derivative would be negative 2x sine x plus 2 cosine x. This is a calculator problem, so I put this into my calculator and find when it has a height of 0. Okay, if there's more than one choice, then also look for the height that is at 0 or an x-intercept, and also changes from above to below. Okay, find that coordinate, whatever that x-coordinate is, that would be what x equals. Round it to the nearest thousandth. You're not done though, because what they want is the area. So you have to remember to plug that x back in over here, or recognize that when you find that y coordinate, no, you can't really plug it in there. You're gonna have to plug it back in right here, okay, or here. So looking for a height of 0, but changes from above to below, happens at 0.860-ish, but that's the x-coordinate. You have to plug that back in here because they asked for the maximum area. So if you plug it in to this equation, your final answer will be what the area is approximately. And that was 1.122-ish, depending on if you rounded too soon. Hopefully you know you should not actually round that number. I can write it on my paper rounded, but don't round until the end. And your final answer for this should have been C. I bet a lot of you thought that the answer was A, and that's because you found the x-coordinate and not the y-coordinate.